Welcome back, everybody. So we are going to do a couple of questions again on time and distance. So we have a car covering a certain distance at a speed of 50 km per hour. If the car had traveled 10 km per hour faster, it would have taken 2 hours less. So if you just think about this, although this seems like difference in speed and difference in time, but the original speed is known to us. So using this difference of speed, I can actually calculate the exact two speeds. Do not misinterpret that. The time part is unknown to us, but that can be handled easily. So we have the original speed. We know the new speed that is faster than the original speed, and the time difference is known to us. And we're looking for the distance the car is traveling. So let us simplify the problem. So we have the original speed as 50 km per hour. The faster speed, let's call it. The faster speed is 60 km per hour, 10 km per hour more. So the ratio of speeds in these two scenarios is 5:6. So this is the ratio of speeds. Again, distance remaining constant. If the speeds are in the ratio 5:6, the time should be in the ratio 6:5, inverse. So we have the two times of the distances, or rather the scenarios given to us. The two times are in the ratio 6:5, and we know that there's a difference of 2 hours between the two scenarios. Now, if you observe these numbers in the ratio 6 and 5, the difference between these two is 1. So if I have to scale it to 2 hours, essentially what I have to do is multiply both of these numbers by 2 and we get the actual time. So 12 hours and 10 hours. So simple scaling idea of ratios. So we have 12 hours traveled with the first speed and 10 hours traveled with the second speed. You can check 50 into 12, 600, 60 into 10, 600 kilometers. So the answer for this problem using either scenario, we get 600 kilometers. So another simple problem based on proportionality. I hope this was understood. If not, mention in the comment section and we'll take them up. Let's look at the next problem. Now, this is a little interesting one. So we have a train traveling a distance of 540 kilometers at a certain speed. If the speed had been 15 kilometers per hour more, it would have taken 3 hours less. Now, the problem in this question compared to the previous one is that we know neither of the speed and neither of the times. We know the difference of speed and the difference of time. That's it. In the previous question, we knew one of the speeds. So using the difference of speeds, I could calculate the other speed exactly. So I knew both the speeds essentially. But here we don't know either of the speed. We just know the difference of speed as well as the difference of time. So I'm just breaking this into two scenarios, let's say. So scenario one is the original one. And if the speed had been 15 km per hour more, that is a hypothetical scenario. So let's say the scenario one, the speed is some s kilometer per hour. Then scenario 2, it is 15 km per hour more. So in scenario 2, the speed is s plus 15. Similarly, in terms of time, if the time in the first scenario is t, then the time in the second scenario should be t minus 3 because 3 hours less, right? Now, even using variables, there are a lot of ways to solve this. You can go ahead and use the basic idea of distance equal to speed into time. So s into t should be 540. S plus 15 into t minus 3 should also be 540. So you can equate these two, the s and t, the s into t thing will cancel out and you'll have an equation on s and t. That is a complicated approach. The easier approach using the variables would be something like this. What I'm going to do is I'm going to represent distance by speed is equal to time, something like this. You can do the other way around. It really doesn't make any difference. And for the second scenario as well, the same thing. Distance upon speed is equal to the time. Now just take a difference between these two equations and you get 540 by s minus 540 by s plus 15 is equal to 3. T minus t minus 3, that is t minus t plus 3. So that is this. And now you use quadratic and stuff to figure this out. Now before we take it into quadratic, there is a small reduction that can be actually done. We can divide the whole thing by 3. So we get something like 180 by s minus 180 by s plus 15 is equal to 1. Do this much at least. And now just do those LCM kind of things. So you have 180s plus 180 into 15 minus 180s is equal to s into s plus 15. So we have something like this. This goes off. And you have something like s into s plus 15 is equal to 180 into 15. Now, this is what I was talking about. Either you can make this into quadratic, or you can try and figure out two numbers, which is at a difference of 15 and giving us this product. So if you can play around with this by exchanging some factors here and there. So what I mean by that is, here also you are having two parts, right? But these two parts are not at a difference of 15. Now, one important observation, if there are two numbers which are at a difference of 15, then one of them has to be odd and the other has to be even, right? Which is a scenario in this case, but the difference is big. So let us reduce it. So what I'm going to do is I'm going to take some odd factors out of this and place it here. So 180, the smallest odd factor that you can think of, I hope, is 3, right? So if I divide this part by 3 and multiply this by 3, so the product doesn't change, and we get something like 60 into 45. I hope you can see that this works out beautifully, right? The two numbers are at a difference of 15, and obviously the lower number will be S and the higher number will be 60, right? So this will be 45 and this part will be 60. So what are we looking for? We're looking for the original speed, that is S. So S should be 45 kilometers per hour. So that's the answer for this question. I hope that was understood. Thank you for joining in. If you haven't yet checked the full playlist containing this video, then check the description for the direct link. Also, if you enjoyed this video and want to stay updated with our daily questions, tutorials, and problem-solving sessions, make sure to hit that subscribe button and the bell icon to never miss an update. In addition to our daily questions, we also offer comprehensive preparation for CAT and other management entrance tests. If you're looking to excel in these exams, we highly recommend checking out these courses in our website. To get a taste of what our courses have to offer, we invite you to take a free demo. The demo will give you a glimpse into the quality and effectiveness of our teaching methods, study materials, and practice resources. You can find the relevant links in the description of this video. Have a nice and successful preparation ahead. See you in the next one.